don't just spend on the computer and learning all the mathematics equations. I mean, they are important for numerical modeling for sure, because that's the foundation of numerical modeling. But you also need to spend some time to really go to the field or go to the lab just to get your hand dirt to see what all the parameters really mean.
Welcome to the Ground Investigation Podcast, a show featuring interviews and insights from leaders in the geotechnical and geo-environmental business world. Join host Michael Taylor as he discusses the ups and downs of running a business in the GI industry, getting geological experts to share their learnings and lessons, as well as their plans for the future, highlighting what they think will improve the ground investigation industry moving forward. Now, here is your host, Michael Taylor.
Welcome to the Ground Investigation Podcast. Today we're digging deep literally and figuratively with Yichi Du. Yichi is a staff geotechnical engineer at Geoengineers Inc. in sunny San Diego and holds a PhD in geotechnical engineering from Texas A&M University. His work dives into the complexities of numerical modeling and expansive soils. From working on projects in Texas heat to California's seismic zones, Yichi brings a wealth of knowledge and some fascinating insights into solving real-world ground challenges. Let's get into it. Yichi, welcome to the show.
Hi, hello everyone. It's my pleasure to come join this podcast to share my knowledge and talk with Michael. And thank you for the invitation.
Thank you very much. Okay, so what inspired you to pursue a career in geotechnical engineering?
Yeah, I start from a long time ago. I mean, when I kind of pursued my bachelor degree back in China, I was kind of interested in how the infrastructure building and just kind of get the idea about that. And then I started to learn that. And, the first thing I learned from civil engineering is always structure. The structure is kind of above the ground and it's the actual infrastructure we see. But then I started to took some classes about some geotechnical and geology. They're talking about the formation and the geotech. They kind of talking about the soil and the rock. And then I find, that's maybe more interesting because structure is very difficult and it has all that force and physics. I need to do all that calculation. But soil I find is sometimes can be really tricky because all that water content and all the different factors like temperature or even chemical can kind of influence these behaviors. And then I found out, it's really funny. And I want to know the reason. And then, so that's why it kind of goes more into the geotechnical engineering.
Excellent. Is it a case of where with structure is because it can be steel and you kind of know certain parameters to a very high degree? And then, of course, once structures are actually interacting with the ground, and the ground has quite a large degree of kind of differentiation or variety.
Yeah.
Okay, so how did studying in China, Florida, and Texas shape your engineering perspective?
Yeah, I think for China, because I start from China, and I think China gives me already a solid foundations about the engineering training and also some mathematics training. So it can give me a good foundation to have potential to understanding more advanced engineering knowledge, and I also get my first glance of all that geotechnical or civil engineering stuff. So it gave me an idea and make me interested in it. And then I went to Florida for my master, but that's only for my first year. And for Florida, it gave me more specific ideas about unsaturated soil because there are several different research topics and interest in geotechnical engineering. But Florida kind of attract me more about unsaturated soil mechanism. And that makes me think, okay, that may be the path I want to choose to learn how unsaturated soil mechanics works and also the numerical modeling. That's Florida also the first place that kind of has some general ideas, basic ideas like, there's numerical modeling. There are several different ways that we can use numerical method to simulate unsaturated soil behavior. So that's kind of gave me an interest. And then when I went to Texas, Texas gave me a well-rounded training from different perspective of geotechnical engineering. We start from laboratory test. So we have some classes like give us the laboratory test. So help me to really get some hands-on experience about laboratory and to really learning how that soil properties meaning to us. And also that classes give me some really good knowledge and background about the physical properties of all those soils. And we also have numerical modeling, especially for geotech in Texas. So it gives me some more hands-on experience and get a better understanding and maybe a more advanced understanding about that. And then after I kind of really doing some research about expensive soil or shrink-swell soil and also some desiccation, numerical modeling, and also I doing some laboratory tests from my research. So I finally kind of get some better understanding. But there's still a lot to learn. But kind of all this pace give me kind of I think right now I can confidently say I learned much more better than when I was in my bachelor. So
Well, you mentioned engineering training. So for the US listeners, everyone will know what an engineering training is. For the UK or Australian listeners and further afield, can you just kind of give a quick summing up of what an engineering training is? Although it's in a way obvious, but there are some a bit more detail that you can perhaps shed some light on.
in US, the first is the classes. Classes is very important because you need to know all that concepts and ideas so that you can start to curious. Okay, so we have this thing and how does that work? So that's the first thing. The classes is really important. Another training I think is the laboratory. Laboratory because engineering is usually about the application. So you need to kind of apply all that things.
Do you become a kind of engineering trainer once you've passed your degree and you've started to actually work in the industry? Is that when you become the engineering training?
Yeah. I think that's the idea. That's the idea.
How long are you an engineering training for?
Oh, that's I think start from 2012. From 2012, yes, around 12 years.
Okay,
Yeah.
fair enough. Okay, so what was the most valuable lesson you've learned during your PhD in Texas?
That's a good question. The first thing I learned is that I should open for uncertainty because before the PhD, during all that classes and all that exams, you always have a solution, the right solution, and you always have the right answer. But that's not how the real world works. So before my PhD, I was always like, if I have something uncertainty and something not under my control, I can get really nervous and get very anxious. But during the PhD program, all this experience, valuable experience I have, and then now I can have a better mindset for the uncertainty. So because it's kind of you can't always have the certainty under your control. So that's the first thing I learned. And the second thing I think is I become more confident for myself to solving problems because through all this PhD experience and all this journey, I gradually gain the confidence that no matter how the problem is difficult it is, I can solve it because all this experience can give me that confidence. So that's two things I think is most valuable. Yeah.
Okay, so how has the transition of being from the, I suppose the more academic side to the actually working in the industry?
That's a big transition actually. But my ideas was I want to understand how industry works, like how exactly the application to the real world so that I can apply my knowledge. I think I think there is some gap between the academia to application to industry, but there are already some universities trying to build up the bridge already for that. But in my perspective, I more want to find a way to apply my knowledge to really go to the application to serve for the community. So that's why I end up with industry here.
Okay, and then in terms of the research on shrink and swell clays, can you explain it essentially and its practical impact?
Yes, so shrink-swell soil, the main feature is that during the moisture change within the soil, this one can have a really huge volume change for swelling and shrinking. And for this one, it can give a big problem because it's unstable and you can't really anticipate where it's kind of swell more or shrink more. So it can give the like the foundation like uneven settlements Like if you this part have more water and you swell more, and this one you have not that much water and you kind of settle here, so the foundation is going to be cracked. So that gives a lot of problem. And for US here, shrink-swell soil is widespread in Texas and Colorado. These two states, and also Wyoming. This middle state has a really high expensive soil. And for West Coast, California also have some moderate expensive soil. So because it's a very expensive soil, it's very widespread and can recurring through the years. So it costs a lot to repair them. So if you check some data, it's annually to design and repair the cost about for the expensive soil is around $15 billion per year. So because it's so widespread and it's recurring so easily, this cost can be exceed the more than like some earthquake or hurricane damage. But things like earthquake and hurricane, one time is a really a big disaster. It can cost a lot to repair and to recover. But expensive soil, because it can recur so easily and it's every year, so it costs a lot more than that.
Keeps you all busy then, I suppose, keeps the business rolling in.
Yeah.
Okay, so how does numerical modeling improve the understanding of expansive soil and desiccation prone soils?
I think it's straightforward. I know it's kind of maybe weird in some perspective, but because in numerical modeling you need to define every parameters, and most of parameters you need to give them some physical meaning. So in that case, you can really because in numerical modeling, if you don't set it correctly, mathematic or numerical correctly, that model doesn't work. So if you want to make the numerical model really work, you really need to have right, maybe not right, but kind of a relatively reasonable explanation of all parameters like associated to the physical meaning and something like that. So it can help me to catch up with some part maybe I didn't really understand or really didn't know about that part. So that's one part of that. It can help me to understand what factors can influence the soil, and the soil can how the soil behavior based on that factor influence. And that's the first one. And the second one, I think it can help to predict the soil behavior. And that's what the industry is doing right now. They use several different numerical software like Plexus or Flex do some prediction to see how it's going to happen and to improve their design. So I think that's how numerical can help. Yeah.
Okay, and then what challenges did you face when modeling unsaturated soils?
Oh, that's a lot, a lot of challenges. I think the most difficult challenge is for unsaturated soil need to modeling is a coupled behavior, because there are several different factors you need to couple to simulate this expensive soil behavior. You need to consider the mechanical, which is a force, stress, strain. That's one factor. And then you need to consider hydraulic. Hydraulic, you also have different factors like permeability, all that water space and all that things. And when they couple together, it also has different ideas. So that's the one thing I found is really hard to modeling unsaturated soils.
Sure. Okay. And in terms, so how did you apply the mesh fragmentation technique in your work in the desiccation cracking? And also, what is the mesh fragmentation technique for those who don't know, including myself?
This one is really interesting. This method is developed by my supervisor, Don Sanchez in Texas A&M. So he want to try to find a easy way to simulate this correction propagation within the soil. So he come up with the ideas to doing the interface elements to simulate this process. So to speak it in general, it's like, because usually finite elements, do you familiar with a finite element simulation?
Yeah, with finite element analysis.
Yeah. So for finite elements, so we know we have different mesh and we have different blocks to kind of doing the simulation. And for this one, we insert, why is for the mesh fragment techniques is because we separate the mesh and we insert the interface element between different mesh. So that's why it's called mesh fragment, because we fragment mesh. And for the interface element, that's the one we actually simulate the cracking propagation. So this one, for this interface element, it used the high aspect ratio element. So this one has its special properties, and it has much details. But if you are interested or anyone interested, I can share my supervisor's paper. It has all the details like how this high aspect ratio element works. But the things like for this one, it has its criterion use the fracture energy to simulate how it's gonna open, this element gonna open. In that case, it can help to simulate the numerical simulate the cracks propagation.
Excellent. So can you share how tools like Plexus 3D and Abacus have advanced your projects?
Yeah, for this one, this project you mean for work or for my PhD?
In general, however's best for you to answer the question.
Yes, I mean I think for this one, as for my PhD, Plexus 2D and Abacus is the good cross validation tools because what I used in my grad school, I used the numerical modeling software developed by my supervisor. So this one is a really good one. It's widely accepted in academia, but when we show this result into industry, they more kind of have a confidence about this commercial software, Plexus Studio and Abacus. So this one is for grad school. But for industry, all these projects, I also was help use this software to doing some projects, and it has a really good ability to predict the soil behavior because it has so much options. It has really established framework for all those stuff, and it's easy to interact with the software to setting up your model. So this one is really a good tool to help you to predict all the site condition and what's going to happen around there, and then you can have idea to improve your design. So, but that's only going to happen if the project has a good budget.
Finding the right staff is hard, really hard. At GI Rec Limited, we understand the ground investigation market inside out and can make all the difference to your recruitment woes. You need to concentrate on running the business, which is very difficult to do without the correct number of qualified staff. We can help you get your time back and lower your stress levels. We only work with talented, referenced, and often entirely exclusive candidates across the ground engineering sector. Wouldn't that be nice? It's not a dream, it's a reality for many of our happy customers. Get in touch with the team now to book a call. Just email info@girec.co.uk to book a call, or click the link in the show notes now.
Okay, so are there any recent innovations as such in numerical modeling that excite you or you're looking forward to for the future?
You mean any innovation in numerical modeling?
Yes.
Yes, for that one, I think for perspective for the numerical modeling, I think right now, I mean, it's going on for lots of years, but right now there are several numerical modeling considering temperature and chemical influence into the unsaturated soils. That kind of really interests me a lot because all that temperature and chemical is and I mean, from mathematics perspective, there are some equation on that, and they are already kind of starting introduced to the model I used back in Texas A&M. But saying I really want to see how that model gonna work to apply to the academia and also in industry.
Right. So what are the key geotechnical differences between working in Texas and California?
Yeah, so this one, in my perspective, because I didn't work in Texas for that long time, I only had an internship for 3 months in Texas. So there's definitely some different perspective from different engineers in Texas. So, but in my perspective, for working in Texas, I was mainly deal with expensive soil problem as we expected because there are lots of high expensive soil in Texas. So, that is a big problem in Texas and maybe a unique problem as well. So that is one. For California, California is more focused on earthquake or seismic design because there are several faults and geology faults across California, and there are also a waterfront. It's a wet coast. So this is more concern here in California because it's kind of more easy to happen. For Texas, there's not much fault and not much earthquakes. So Texas don't really design the civil engineering infrastructure based on earthquake, but they do have some marine design, like offshore infrastructure. So that's kind of a different purpose from California. But for Texas, they do have some different interesting projects or maybe different concerns. But because I didn't spend that much time in Texas, so in my perspective, that's the differences. Yeah.
Okay. So what were the kind of projects that you dealt with in your 3 months in Texas?
Yeah, in my 3 months, that was quite a good experience actually. That one was because I was pretty new from school, and the one big understanding I should have is the field work. The field work is an important part for geotech. So I get lots of experience of field work from that experience. So I get lots of understanding of the drill rigs and also the drill method. I see a different like truck mounted drill rig and also some mush buggy. Mush buggy, that was really interesting to me. That one you can drill over water for that one. Yeah. So, but it's a very shallow pond. You can't really drill in a really deep water. But that one is a really good one. So I got lots of good understanding of field work, and they also helped me to draft some proposal and report. So for that one, it's more like a whole industry project process training. And I also got some experience through writing the report and proposal. I got some understanding of how do they design the foundation associated with expensive soil. But because that's a relatively short term, it's only 3 months. So all that projects is about expensive soil, but they have some different projects coming in about some solar farm, and solar farm foundations can have different requirements, but I didn't get a chance because I need back to school. So, but yeah, but that's from experience. That's all I have from Texas.
Okay. But you like your time out in the field then when you were there?
Yeah, yeah. In the field, it's a really good learning experience because you can see everything, you can feel everything. So that way, the all that stress force is not just a number. You can really see what is the main. So it's kind of help me to maybe design some foundation in future so that I can really can understand. Okay, 2000 PSF. Okay, that's a really high experience because I kind of get some feel on the field work. So
Yeah, it's always beneficial to have the time on site, I suppose, depending on exactly where you're wanting your career to go. But you often get, I say this quite a lot on the podcast, you often get people who kind of want to, not go through that route. You want to just go straight to the office, essentially. But I think that kind of limits to a degree. It depends exactly what the plan is for the future for that particular person, I suppose. But yeah, being out, I suppose, either in the baking sunshine or in the rain, sitting by a drilling rig, liaising with drillers, looking at the core and the samples taken, testing.
yeah,
Yeah, it's kind of a different site, I suppose, isn't it? Something else
yeah.
to take in.
Yeah, I know it's not desirable for everyone, but from engineer perspective, if your career goal is to design all this structure based on different circumstances, you need to understand what's actually happening in the field. So
Yeah, it definitely helps. So, how do you see numerical modeling evolving in geotechnical engineering?
involving, I think for now there are different methods considering numerical modeling. So it's becoming more complicated, and I can see it maybe accurate, more accurate because you have more complicated framework and all that kind of stuff. So it's a really big step right now, and it's also benefits from our computational more advanced computational method. So we can spend less time to doing more computation than before. So that's really a big step. So it can help us to develop more accurate model for us. So I think that's really good evolving. And right now, there's another method that's AI, artificial intelligence, and machine learning kind of joining for this word. But they are different for numerical modeling, but they are also a good tool for us. So I think at some point this machine learning can be also a really helpful tool as numerical models. Numerical modeling help us right now.
Yeah. Okay. So how much do you use kind of AI at the moment?
Right now, actually, it's the really start point. I mean, there are a lot of machine learning application in other industry. But for geotech, I know some company already start that. So it's just barely start right now. And actually, for geoengineers, we are forming a team. Forming a team to kind of trying to apply this cutting edge method to our projects because we know it's a trend and it's gonna be happen at some point. So we want to start to prepare, and we don't want to lost in this trend. But the things like because it just start, and we need to understand and to how to apply this into our project. But we are excited for it, and we are really interested to see how it's gonna going and how it can actually happen within our projects.
Yeah, I would say so. I mean, the industry in the United Kingdom, at least, it can be a little bit slower to take up some of these things and get moving with them. But I mean, eventually, it's only going to get better. AI, isn't it? In 10, 20, 30 years, you can, I can't even fathom where it could potentially be. So, I mean, if it keeps going at the rate it is, then yeah, who knows?
Yeah, it's gonna happen at some point. It just people, I mean, for geotech engineering, people are start to considering how can we actually apply this. It's people already kind of start to think of some different ways, and some already have some good ideas of it. But it's an interesting point. It's a start point, and people are learning. Yeah.
I suppose if those companies that are willing to invest now for the long term, I'm sure in 5-10 years we'll be in a really good position potentially, and others will be catching up.
Yeah, but it's tough to start. So.
Yeah, it's hard to start. So how important is it for engineers to balance experimental testing with modeling skills?
I think it's really important because through my based on my experience when I doing my master research about all the distribution cracking, all that model parameters, for me because I didn't have that much experience that time for the laboratory, all that model parameters is just a number to me. And I was thinking, oh, I was just playing some number to make the model work. But that's not how numerical modeling it is. So numerical modeling different parameters, it has its physical meaning. So it has its many means. You need to make it reasonable and you need to understand and to make, and it also help you to doing your numerical work. So during my PhD, I started doing a lot more laboratory testing, and I kind of apply all that laboratory testing into my numerical model, and then at some point I suddenly understand, oh, so that parameter means that because of this laboratory work. So this kind of like an interaction between each other. You know, numerical modeling, it can some point help you to understand your laboratory. You can have some ideas to design your laboratory work. Based on understanding of laboratory work, you can start to have a good understanding of numerical modeling, can improve your own numerical modeling based on that. So I think it's really important to understand both ways because they are kind of interact with each other.
Sure. So in terms, well, what advice would you give to young engineers just starting out and interested in numerical modeling?
So first suggestion I think is get your hands dirty. Don't just spend on the computer and learning all the mathematics equations. I mean, they are important for numerical modeling for sure, because that's the foundation of numerical modeling. But you also need to spend some time to really go to the field or go to the lab or whatever it is, just to get your hand dirt to see what all the parameters really mean. And then it could be a huge help for you to understand numerical modeling. And second one would be don't spend too much time on the mathematics. Mathematics is really important, but it takes time to understand that. So if at first glance you don't understand, it's all right. Don't kind of blame yourself. It's like, why I can't understand it? it just takes time. So if you can take it easy and give you some time, you will understand all these mathematical equations at some point. Yeah, I think that's all.
So, do you think there's a gap between academic research and industry practice? And if so, how can it be closed?
Yeah, for me, I think it is a gap. And for example, because academia sometimes is too advanced, and I mean, it's a good thing because it's academia. You need to do some pioneering work, so that's how academia works. But sometimes you are too advanced, and the industry maybe not because you're the industry. You need to application. You need to kind of make it easy. You don't want kind of giving a 3 months class of all the engineers before they can really actually do their project. That's not gonna work. So I think this is one gap. But the good things here, there are a lot of universities. I mean, Texas A&M is one of that. They are starting to kind of build up a bridge. They set up some projects to work with the industry consultants, engineering consultants here to kind of connect with each other. I mean, Virginia Tech was the first one to doing it, and Texas A&M is kind of following them. And there's also other United States universities that are doing that. So they just work with the industry bring the problems, the university kind of based on their problems and start to working on their problems to apply the academia knowledge to help with the industry. So I think that's a good point. Yes.
Okay. And then how can geotechnical engineers better communicate the technical results to non-engineering stakeholders?
That's one, that's why I must say to make it simple because all those complicated explanation, all that engineering stuff, we can make it simple to explain. If we can't explain the simple way, that means we don't quite understand. It's always like that. I mean, when we have some a good class from good professors, they can do it so easy because they really understand everything. So I think what we should do is like we should understand based on our understanding, make more understanding of all that engineering perspective, but make them very easy, very straightforward for everyone can understand. So I think that's the point.
So, what has been the most rewarding moment in your career so far?
In my career so far, I think first is to get my PhD degree. That's a really rewarding moment. Because spend that much years, all those experience, finally get the degree. That's a really rewarding moment. And the second one, I think, is when I start to work with geoengineers, I start to really apply my numerical modeling experience to solve some really challenge projects. So that one is a really another really rewarding moment because that's what I always want to do, apply my knowledge to apply to the works and the geoengineers making it happen. So that's another rewarding moment.
Okay, so if you could tackle any global geotechnical challenge, what would it be and why?
I think the first is expensive soil problems. So this one is still there are already a lot of mitigation ways methods for that, but I think there's still a lot to do about it, and that's what I PhD research about. So that's definitely one thing. Another one maybe is the machine learning application because that's definitely gonna be a really helpful tool for us. So.
Okay. And what future projects or topics are you most excited about exploring?
Future projects, for right now, the first thing comes to my mind is the earthquake because I didn't have much earthquake background from my grad school, but I really want to learn this knowledge. So that's what I really excited about exploring through with geoengineers about how that earthquake works, how do we design this earthquake. And second one is the numeric modeling, definitely. How can we better apply numeric modeling into our industry projects? There have different factors, but I want to find maybe a better way for could benefit both me and the company together, and also the client. Client is the most important part here. Yes, and the third one is the machine learning. Yeah, machine learning. Just can't wait to see the potential and how the machine learning can benefit us for all the company, for the clients, and for me to to kind of improve our projects and to maybe can give a better design for our town community.
Perfect. Well, that brings us to the end of the questions, and I think the most technical questions we've ever had on a podcast. So for some, that's going to go straight over their head and might inspire them to look up. And for others, it would be some fantastic insights. So thank you very much for taking the time, Yichi, in coming on and giving us your thoughts.
Thank you, Michael. I thank you for inviting me to here, and to give me the opportunity to share my thoughts.
Thanks for listening to this episode of the Ground Investigation Podcast. If you have enjoyed this episode, then please support the show by leaving it a 5-star review wherever you download your podcasts. For more information on what was discussed in this episode, click the link in the show notes now.